Very good evening, students. Today we are going to discuss about design of 8x3 encoder or octal to binary converter. In last video we have discussed design of 3x8 decoder, correct, which is called as binary to octal converter. This is the block diagram for that one, which has 3 input and 8 output. Now encoder is always just opposite to the decoder. Encoder is available in the sender end and decoder will be available in the receiving end. Okay. Now it has 8 input and 3 output, and it is also called as octal to binary converter because octal is having 8, correct, 0 to 7. Same as 0 to 7 input is there and will be getting equivalent 3-bit binary number, hence it is called as octal to binary converter. Now in any combination circuit, the first step is forming the truth table, making its or confirming its input variables, number of input variables and output variables. Now we have 8 input variables and 3 output variables. Okay. Now decoder 3 input variables and 8 output variables. Now if we swap the table, truth table in the decoder as input and output, no, then we'll get truth table for the encoder. 8 inputs from D0 to D7 and 3 outputs X, Y, Z. These are the arbitrary variables. We can consider even A, B, C also. Correct? Receives 1 means the remaining input will be 0. Okay? So the remaining input will be 0. Now this D0, no, this will be encoded as, D0, no, 0, equivalent binary value, 0, 0, 0, like that it goes on. And then similarly for the next bit, no, for the next case, suppose if D1 receives input, the remaining input will be 0. The remaining input will be 0. So what happens? The D1 will be encoded now. What is the equivalent binary value for 1? 0, 0, 1, correct? 0, 0, 1. Suppose D, for example, D5 receives input. Okay, the remaining input are 0 obviously, because in encoder it receives input, any one input only receives 1, correct. So now for example I am having D5, input is 1. Now how it will be encoded? 5 will be encoded, so 1, 0, 1, like that it encode. Okay. Suppose D7 here, D7 receives input 1, correct, the remaining inputs are 0. So now this D7 will be encoded as equivalent binary value as 7, because the D7th input is receiving, correct. So 1, 1, 1. So the entire truth table for 8x3 encoder will look like this, correct. So at any time, any one input receives 1. The remaining input will be 0. That will be encoded now, the corresponding binary number, correct. So now as we are having 8 input variables, so we have to go for 8 variable K-map, correct, to get the expression for simplified expression for output, but it is not possible. But the shortcut method is the X is having the min term for here, here, and these 4, correct, these 4, X value is 1 in these 4 cases, correct. This one is because of D4 input, this one is because of D5, this one is because of D6, this one is because of D7. So X can be, see here, written expression as it receives 1 because of D4 or D5 or D6 or D7, correct. We already told any one input only receives 1, the remaining input are 0. So either X receives 1 because of D4 or D5 or D6 or D7. So this is the simplified expression for X without need to go for K-map, correct. Then similarly for Y where until it receives 1, here these 2 ones are there, and see the remaining 2 ones are here, correct. Y receives 1 because of the input D2, and this one is because of D3, this one is because of, see the column, correct, this one is because of D6 and D7. So shall we write like that? See here, so Y as because of 1 due to D2 or D3 or this, the remaining two ones are 6 and 7, correct. So we can write this as D6 or D7. So D6 or D7, correct. Then for Z we can write, correct, for Z, no, where until it receives input here, this is because of D1, okay, this is because of D1, and this is because of D3, then this is because of this, in 1 is because of D5, see here, and this one is because of D7, correct. Now how we can write is that, so D1 or D3 or D5 or D7, okay. Then we have to draw the logic diagram for this. The corresponding logic diagram will be like this, or you can put 8 vertical lines. From there you can make the tappings like we do in decoder, correct. Thank you.